So today in this video, we'll be looking into the configuration and setup for Order Microservice for our application. What is the responsibility of this microservice? So from the UI, the user is given a chance to see the list of restaurants. Now from that list of restaurant, user chooses one of the restaurant. Then on the set of all the food items for that particular restaurant, he selects some restaurant item list, some food item list. Once he is done with all his order configurations for that particular restaurant, then at the end he hits the order now button. So in that order now scenario, you have the list of food items, the restaurant from which the order has to be picked up, and the details of user has to be there so that that particular order must be delivered to the right user at the correct address. So this microservice, Order Microservice, is responsible to save all the information of restaurant details, user details, from where to order pickup, to where to order has to be served, and the food item list that has to be served. So the three things that has to be maintained by this microservice becomes his responsibility. That is to maintain the food item list, to maintain the restaurant details, and to maintain the user information details. Now we have the user information details already in the user microservice. We have the restaurant details in the restaurant listing microservice, and we have food item details in the food catalog microservice. And a mix of all these three becomes the source of information for this microservice. As of now, I'm just going to save all the three informations in the order service in the backend. Later on, we will use this information to expand our example to have multiple interactions with either the emailing service and many other stuff. So as of now, the only one REST endpoint I'm going to create, that is to save this order in the database. But a very important change which this Order Microservice has and no other three microservice has is the change in data source. Now I'll tell you why we have changed the data source from relational DBs that we have used here to the NoSQL DB, that is MongoDB here. REST all still remains the same. We are going to use a microservice architecture, REST endpoints, Java 11, Spring Boot, Lombok, Eureka client. Nothing new, nothing much new. Now to install the MongoDB in your local, this is the link. MongoDB installation manual will be there. You can always go here and select either, if you have Linux, Mac OS, Windows, you can always have the community edition, which is free for you. Next, what you need is Compass. So like we have the SQL Yog here, right? Where we see all our relational database tables and everything. Similarly, we have something called as Compass. So MongoDB Compass is the one where we can see all the documents that is saved in your MongoDB connection. We'll be coming back to this Compass soon. So both the links will be given to you. Also, you can find it in mongodb.com docs itself. This is master installation for Compass and docs manual for installation of MongoDB itself. Now, let's first see why we have moved to MongoDB and not the relational database. So let's first see that. So we are here in Order Microservice. What all three things this microservice has to save? It has to save restaurant details. Also, it has to save user details and food item list. And for each order, it has a unique order ID. So, if you would have gone to relational database, how would your database would look like? How complicated your query to fetch everything as a single order would have been difficult. So, you would have one table like we have in user details microservice, a user table. Then you would have one more table. Here the primary key was ID. Here you would have one more table for restaurant details, where you would have restaurant ID. Now what you would have is one order details table, where you have an order ID. Then you would have this particular ID is to be taken from which restaurant ID. Then you would have one more column for which particular user ID this particular order is placed. And here we are not even considering the food list. If you would have food list items, then you would have food list item ID also, item ID, and food item description and everything in another table. So there will be 4 or 5 tables in your database first of all. With the order ID, you won't fetch everything. Then you would have to put where order ID is this, join on column restaurant ID, join on column user ID, join on column food item ID. Doesn't this seems very much complicated? Is this really required? These many tables, so this is going to the primary key, this is going to the primary key, you have to make this as a primary key, this as a foreign key, this as a foreign key, and multiple more foreign keys. Doesn't this seems very complicated to you? Is this really required? Now I'll give you one option and then you choose between both. So you can have one big document, NoSQL of document, a JSON type of document, where you have order ID as one, then you have restaurant, a whole pojo having restaurant ID, restaurant description and everything. Then you have food items. Then you have one more as user details. And that's it. This is where your order ends. So when you fetch the order document with order ID 1, you have everything in place. No need for any kind of foreign keys. No need of joins. No need to maintain multiple tables. This seems very much easy. So that's the advantage of NoSQL database, and that's why we are using NoSQL database for order service. I'll show how beautiful it looks when we are done with the saving an order in the database. Then you will understand how beautiful this document looks like, how simple and how easy it is to maintain. And that is why I moved from MySQL DB to NoSQL DB, that is MongoDB. So let's get started and create the order service now. Create a new Java project with Maven as a build tool, 2.7.12. Now this is for the order service. So com.codedecode, artifact ID can be order, name of the project can be Order Microservice, and this is a demo project for Order Microservice. The package name will be in the reverse order of organization, com.codedecode, and the artifact ID order. Java version 11 I'm going to use. Now important part, dependencies. First, I'm lazy enough, so Lombok. Second, for the Spring Web. Now remember, here we do not use MySQL. Here we use MongoDB. So we need a dependency for MongoDB. Spring Data MongoDB, NoSQL database. Next, we need Eureka client, because I want to make this application a client to the Eureka server. With this minimal configuration, let's start adding this project to our IntelliJ and let's start coding this web application. So we have this Order Microservice in our IntelliJ. This is our main application. Let's see the form.xml. We have the Spring Boot starter data for MongoDB. We have the web application. We have the Netflix client. We have the Lombok. I'm just going to save a particular order that we receive from different sources, like from front end and from user microservice, adding all that to the NoSQL DB. So let's get started and create the web application layers, that is controller, service, repository, entities, and the DTOs that is going to fetch the data from multiple, and the DTOs has to be small. That's not how the package should be named. This will be having the DTOs that we need from other microservices or from the front end, the data that we will be getting. So let's start by creating the details that we're going to get from the front end and from the user details microservice. First, we're going to create a restaurant. This restaurant is going to have the @data, $given constructor, and no argument constructor. This restaurant is going to be the exact same DTO that we have in the restaurant listing microservice. So let's open our restaurant listing microservice and fetch the restaurant DTO variables from there. So it's going to have ID, name, address, city, and restaurant description. So we have restaurant in place. Next, we need the list of food items. So we will be adding a DTO, food items. This food item DTO again is going to have all the fields of food items and all the 3 annotations of a DTO. So we have the food item with us, whose list will be saved in the DB. We have the restaurant whose details will be saved in the DB, the user DTO. Again, this user DTO will have all the 3 annotations and the user details same as what we have in the user information here. So with this, our 3 DTOs that has to be saved in the database is there. Food item DTO, that is going to be the list which is going to be coming from the front end. The restaurant DTO and the user DTO. Now we also need one more DTO which we are going to get from the front end. That will be an order DTO. Again, 3 annotations. And what all things order DTO will have that we are going to get from front end, that will be the list of food items DTO. And secondly, we are going to have integer user ID. And thirdly, we are going to have all the fields as private. The thirdly thing that we need to have is restaurant details. So restaurant photo again. These 3 things we are going to get from the front end. Now we need to generate the order ID automatically and save it in the MongoDB document. If you remember, using Hibernate has a big benefit. Whenever you do the auto generation of your ID, it automatically creates a sequence table and maintains the sequence for you. So whenever you would have used the SQL, your sequence would have generated as 1, 2, 3 automatically. But now MongoDB doesn't do it for you. You don't have that luxury at all. So you also need to create a sequence generator for each order that you save. So now in the entity, the only thing that you're going to save is order. Now that is going to be saved with order ID. So integer ID or order ID. Then you will have food item list. Since we are going to have everything as private, we will be needing @data, @all argument constructor and @no argument constructor. And to make this entity as document in MongoDB, you need @document for Mongo. And you name this document as simple order. That is going to be saved in your MongoDB as a document. You have an order ID that you have to generate sequentially. You will have food item list that you will get from the order DTO. You will have also the restaurant details. So order is going to have the restaurant details also. Also, it's going to have the user information also. So private user DTO. So you will have 3 POJOs that is added in your document. So basically 3 inner JSONs will be there. This will be the list of JSONs even with the list of food items, the restaurant and user DTO, and that makes the complete order that has to be saved in the DB. Now let's quickly start by creating a repository. This repository is going to be the Mongo repository, not the JPA repository. So it can be order repo, @repository. This is not going to extend the JPA repository, but rather the Mongo repository. And it's again of type generic, going to have the entity as order and its primary key, that is integer. And this has to be of type interface. So your order repository is going to be of type interface, which is extending the MongoDB repository. The repository is in place. Now we need to create a service layer. That's going to be a simple class order service. This has to be @service. It's going to auto-wire your order repository. Also, it will be auto-wiring the sequence generator, which we are going to create in the service soon. In the controller, we need order controller. This is going to be the REST controller for us. Also, it has a request mapping with the base URL of /order. And it's going to have an auto-wiring of order service. As decided, there is only going to be the one REST endpoint as of now that is going to save your order in order DB as a document in MongoDB. What you need to do is to have a post mapping to save an order in MongoDB. So @post mapping to save your order, and it's going to return the order DTO to you. But the order DTO doesn't contain the user information. So what I'll do is I'll rename this order DTO from front end. This is going to be a DTO that is going to be received from front end to you. Now we need a order DTO that is going to return when exact order is saved in the DB. So what I need is, I'm going to create one more order DTO, which is a true replication of entity here, and it's going to have all these fields. With that in place, we're going to return a response entity having a real order DTO, which is the exact replica of entity of order in our DB, and we're going to add or save order. To save an order, we will be requiring a request body where we are going to get the order DTO from front end. So what we are going to get from the front end is list of food items, restaurant, and the user ID. So this is the thing that we are going to get from the front end. So this is input to us, and we'll name it as order details. Now what we need to do is to save this in the DB. So simple order service dot save order in DB, and it's going to take order details as an input, and it is going to return you the order DTO which is saved in the DB, and you're going to return new response entity with order which is saved in DB and HTTP status as created. Let's create this in our service layer where you're going to get the details from front end. Your task is to add the list of items and restaurant as it is, but for this user ID, fetch entire user detail and then add it in your order entity. So in the order service, first let's create the order entity directly. So order entity, order to be saved, equals to new order. You have the all parameterized constructor also. So for that, you need order ID, which is not there. You need food items and restaurant, which is already there, and you need a user DTO completely, but you have only the user ID. So what you can do is, before doing this, let's create the order ID first. So let's create one more class as sequence generator, and we'll mark it as @service, because it is also going to have the business logic to save an extra field, that is order ID, in our orders document. This class is going to auto-wire the Mongo operations. This Mongo operations is basically an interface having multiple operations like execute command, execute query. You used to have find all, find by ID. All those operations are actually enclosed with Mongo operations here. Now, this service is going to have a public method which is going to return you an integer, which is going to be the ID for the next order getting generated. So, int generate next order ID. Now, to generate the next order ID, we always have to save the previous order ID in some document, right? So, here in the entity itself, you need to create one more class as sequence. This class is going to be saved as Mongo document. So you have @document here, and we're going to name that as sequence. Also, you need @data, @all argument constructor, and no argument constructor. This sequence is going to have a simple fields ID and sequence, where @ID will be private int ID, and next is going to be the private int sequence. So the document is ready in the generator. So here I'm going to paste the whole logic to fetch the sequence from the sequence document and update it to 1. If the sequence document is not available, then initialize that sequence with 1 and update and insert that document in the document DB. So I'll write the whole query here and then we'll explain you why did I do that. So I've written the whole logic to fetch the sequence document, get the key of sequence, update it by 1 and return it. If it is not there, then initialize it with 1 and upsert as true. So what does this line number 21 do is, from the Mongo operations, find and modify. What does find and modify do? The find and modify is used to find a document and modify it in single atomic operation. It is going to be a one single shot where your document will be modified. The next statement says query where your document ID is sequence. So where is your document ID sequence? So this is the document which is name ID, who's having the underscore ID as sequence. This specifies the query criteria. Remember, this find and modify has 4 things to take: a query, update operations, options, and the entity class. These 4 I'm going to explain you now. First is the query. The query criteria says with a where clause to specify which document it has to search. The name of the document is given here and the brackets. So the document for name for us is sequence. Where is the document name sequence? It is here. The document name is sequence. Next, the second parameter for this is update. Update says get the key sequence and update it by 1. So where is this key in the sequence? This is the key in the sequence. So it says fetch it and increment it by 1. So this part is the update operation. The update method says that fetch the value of sequence and update it by 1. The third part is options. This options says options dot return new and upsert true. So here options for find and modify operations are defined. The return new as true option indicates that the modified document should be returned as a result. So it says return, yes, it should return. And what it has to return, the new modified document has to be returned. And upsert true. This specifies that if document matching the query is not found, that means initially when you don't have the document in your document DB, then a new document has to be created. The fourth and the last parameter for this is entity class. This entity class is the class type of the document. Now, what is the class type? The class type for this document is sequence. Hence, at the end, you have sequence.class, which has to be modified. And that's where you get your counter. Now, the counter.getSequence will return you what you have updated with 1 in the document. So, overall, what does this whole code do? First of all, it performs the atomic find and modify operation. It searches for the document with the document ID mentioned as sequence. Once it fetches the document in the memory, it fetches a sequence key and increments it by 1 and returns the updated document. If the document doesn't exist, then a new document is created with the specified ID, that means sequence, and the value for the sequence is going to be 1. So every time either it will be incremented by 1, but for the first time it is going to create by 1. Once this is clear, this is the logic to generate a new order ID. When you have the new order ID getting generated, Here, when you're going to save it in the database, you're going to first generate new order ID, then only save. So first here we need to auto-wire our sequence generator. And we need to call this sequence generator's method, generate next order ID. What it is going to return you is an integer, which is the order ID, new order ID now. So integer, new order ID. For this new order ID, you're going to give it as a first argument. When you're going to create the constructor, you're going to give the order ID. Then list of food items. Where you get the full list of food items? From here you get the list of food items. So order details dot get food item list. The third parameter for order is restaurant. This is also coming from the front end for us. So order details dot get restaurant. And the last parameter to create this object is the user DTO object. Now to get the user DTO object, what you have in your order that is coming from front end is user ID. Now you need to hit the user microservice and fetch the complete user details and save it here. So for that, now you need a code to fetch order details from user ID. And you're going to pass order details dot get user ID that you're getting from the front end. And it's going to return you the user DTO, which you're going to pass here in as a fourth parameter. And that's how your order to be saved will be created. Now to fetch this order DTO, let's create one more private method in the service layer. Then we are going to call the REST template and hit the user detail microservice. To hit the user detail microservice, what you need is a bean for REST template. So again, like we have done in the previous microservices, we need a bean, a load balanced bean for REST template. So public REST template, get REST template and return the load balanced bean for REST template. Now in the order service, we just need to auto-wire this bean. So @ auto-wire REST template. Use this REST template to get for object the URL and response type. So I know that my response type is user DTO. What is the URL? So URL is going to be http:// not the localhost 8080. Why? Because it is going to be served as a Eureka. So we need application name, that is user service, that is going to be searched and served by Eureka to us. So http:// user service /. Now in the user service, this is the base URL that we need to hit first. Then we have fetch user by ID and then you pass your user ID. And you're going to pass it to user DTO.class so that whatever you get as a response, you get here. You can directly return it here. So as soon as you hit the user service with this user ID, you get the user DTO object, you can directly return it and then save it. The last thing that you need to do is to create a mapper again, because the thing that you're going to get here is order and what you're going to return is order DTO. So next you need this to create a mapper. Next package is mapper and the name of this interface will be order mapper. This is going to be mapped as @mapper. Now you don't have @mapper here because we didn't add the mappers in the dependencies. So let's quickly add the mapper dependency. We have added the dependency for map struts. Next we need is a plugin. With everything in place, let's update the Maven project. And then now we get the proper @mapper from org mapstrut mapper. Again, we need to create an instance and 3 methods to create order from order DTO and order DTO from order details. Similarly, what we have done in previous 4 ones. So we have these 2 methods ready, map order DTO to order and order to order DTO. And we're just going to use this order mapper here and return it. Before that, we are going to save this order in the MongoDB. And how to save this order in the MongoDB? Simple, order repository.save. So with this in place, our code is done to fetch the next order of sequence generator, fetch the user details from the service, create a new order, save it in DB and return as a DTO. But one thing that we are forgetting is to add the properties file. So I'll be adding new properties file here as application.yaml. Again, 4 things. Run it on server port 909x. So I'm going to use 9094. Make it as Eureka client and register it to Eureka server. Third, to give it Spring application name so that with that name that is registered to Eureka server. And fourth, the link to connect to MongoDB. So let's do all those things together now. So here we have server port 9094. Here we have Eureka client configuration, register it to Eureka server. This is the application name with which on Eureka server it will be registered. And now these are the few changed things that we have in MongoDB when we want to connect to the order database in MongoDB. So in MongoDB at localhost, this is a default port number like we had 3306 for MySQL. This is 2701 for NoSQL DB MongoDB. Again at localhost, this port number at this order DB, we need the connection, and with this a new order database will be connected. Now our configurations is also ready. See how Compass looks like now. So if you can see, this is our MongoDB Compass. You can see we do not have a database here with order DB. Let's see if it creates one with the tables here. Let's run this application. Since our Eureka server is up and running, it won't be a problem. So you can see it is started. Let's create another folder for our Order Microservice. Let's add a request to add new order in database. It's going to be a post mapping with localhost 9094 with the controller /order/save order, and in the body we would be giving a raw JSON. Let's try adding this food item list with one food item and one restaurant with user ID 1 in the DB. So you can see when we hit, we have the order details from the front end where we have food item list, user ID and restaurant details coming perfectly fine. Let's save this order in DB now. So we found one issue here. No service available, no instance available for user service, because you are hitting it with user service and you can see our user service is shut down. That is why this error. Let's quickly go ahead and run user service also. And in the Eureka, let's see that both the applications must be registered perfectly fine, the user service and the order service. Let's go to the Eureka dashboard. So on the Eureka dashboard, you can see we have order service registered with 9094 and user service also registered 9093. So both our applications are up and running now, the user service and the order service. Let's again try hitting by clearing the console now, and also simultaneously let's see how is the Compass looking right now. So here if you can refresh, you can see our sequence is generated perfectly fine with sequence 1. Since we have not created this collection, as told, if this sequence is not present in the MongoDB, then it will create automatically with sequence value as 1. So that is done. Let's hit the postman. You can see our request comes here. Our order details are perfectly fine. Let's see whether we are able to generate the new order ID. So yes, the new order ID is 2. Because we have done it again. Initially we were having an issue with user service was not up. So now the sequence that is getting generated is 2 because we already had a sequence that I have shown you here. Now it's going to fetch the user details using the REST template. Let's try. And yes, we got the proper user response from the user microservice also with user ID 1. Name as code and whatever we have saved in the user microservice with user ID 1. Now let's try to save this in the MongoDB. Let's refresh our MongoDB. And yes, in the order we have a proper data saved with order ID as 2. The food item is a list with dal fry and everything that we have added. With the restaurant with every details of the restaurant. With user with every details of the user. And this is the class, which is the entity that is saved in the orders document. So your order document is created perfectly fine in the MongoDB. And see, now you can distinguish between your NoSQL DB and SQL DB. It's so easy. You don't have to maintain 4 different tables. You have everything as a 4 different objects in the same POJO or the same DTO. That's why I always say when you have multiple joins, multiple foreign key, primary key combinations, rather go to the NoSQL DB and not the MySQL DB. And let's go to the console and see, yes, you have created 201 status with your food items, with your restaurant, with your user ID getting perfectly populated. These two are the exactly same that you have passed in your request here. But what you have passed extra is just the user ID. But whole user information is coming from the user microservice. So this microservice is also created perfectly fine. All the backend services are done as with the end of this video. In the next video, we will be working on the Angular application, that is the front-end application for this food delivery application. Angular is going to be used. All these 4 microservices will be used to showcase the list of restaurants, the list of food items in each restaurant, the user details, and to save that order in the DB. So all these 4 microservices that we have created in the previous videos will be used in the front end also. So let's meet in the next video and create the front end for this application.